types of angles. They are corresponding angles and alternate angles. And basically what these two angles are the angles that you get when you have two parallel lines and then you draw a line through a straight line through both of the parallel lines. As you can see, that creates 8 angles. In this particular setup, there are 4 angles where our line going through the parallel crosses the upper line, and there are 4 angles at the intersection where our line going through the parallel crosses the bottom line. And we're going to discuss what these angles are called and the difference between them. There'll be a third part to the video towards the end where we'll show how alternate angles and corresponding angles give us a very, very important piece of information. With them, we can show exactly why we know that a triangle is made up of why a triangle is made up of 180 degrees. We'll be using alternate angles and corresponding angles to show this. Okay, let's take 2 parallel lines. And now let's draw a straight line through both of these lines. Notice that the angle A is the same as the angle B. Why is that? It's because with our line passing through the parallel lines, it crosses over each line at exactly the same angle. Therefore, these 2 angles are the same. But it also means that these 2 angles are the same. It also means that these 2 angles are the same. And it also means that these 2 angles are the same as each other. So you have 4 examples of corresponding angles when you draw a line through 2 parallel lines. Also notice that these corresponding angles form a kind of F shape. You could call them F angles. That's not what they're actually called. If you were doing homework or writing a test or taking an exam, you don't call them F angles. That's just to remind you what they look like. We just call them corresponding angles, but they essentially form the F shape. So these are our corresponding angles. Actually, I forgot to mention, what we notice is that with corresponding angles, they will be on the same side of the line. So they'll either be on the right side or on the left side. All corresponding angles stay on the same side of the line. With alternate angles, something different happens. So, again, let's draw our 2 parallel lines, and let's draw a line, a straight line going through them. Now, take a look at this angle, and watch what happens if I flip this around 180 degrees. Look, it lands in exactly the same spot as this other angle, and it's exactly the same size. So in other words, the angle A and the angle B are the same size, but they're not corresponding angles because they're not on the same side of the line. They're on the opposite side of the line. And because they're the same size on the opposite side of the line, we call them alternate angles. A way of remembering this is that alternate angles normally form what's called a Z shape. So they'll be in the corners of the Z's. it's either a normal Z or a backwards Z. But in any case, they're not really called Z angles. That's just to help you understand where these alternate angles are in relation to each other. When you're taking a test or an exam or doing a homework, they're called alternate angles. And it's quite clear to see, as we said, alternate angles occur on opposite sides of the line that goes through the parallel lines. So there you have it. You have the, what's it called? I'm forgetting the corresponding angles which occur on the same side of the line. So either the left or the right side of the line, and we call that an F shape. It's an F shape. That's how you can know what the angles are. And then the alternate angles occur on opposite sides of the line, and we can identify those with the Z shape. So now we're going to move on and see how this helps us determine that the angles within a triangle add up to 180 degrees. So I just wanted to give this quick tip on how we recognize alternate angles, because I think I didn't focus enough on this. The way you can think of it is, imagine you take your diagram and you flip it 180 degrees. Now, what happens to an alternate angle, to the two alternate angles, when you flip the diagram 180 degrees? Well, they actually just swap places. That's what happens in an alternate angle. So angle A and B will actually just swap places, and your diagram will look exactly the same. Let's actually try that with all four of our alternate angles that we showed earlier on. So let's take our first angle, flip the diagram 180 degrees, and look what happens to the angles. They just swap places and you get the angles in exactly the same place. Let's take the other one. Again, flip it 180 degrees and look what happens. You get exactly the same shape. All that happens is the angle swap places. These are how alternate angles work. Let's try it again. Flip it 180 degrees and you have exactly the same shape, because all that happens is the angle swap places. And again, we have this shape. Flip the diagram 180 degrees and the angles just swap places. You get exactly the same image. So that's how you can tell what the alternate angles are. Just imagine if you can flip round. You may even need to turn the page that you're working with 180 degrees, and then that will show you the position of the alternate angle. So that's a useful tip on finding alternate angles. So first things first, let's start with a triangle with the internal angles. Now, we don't know what any of these angles are, and it doesn't really matter, because what we're doing is we're assuming that the sum of all three angles, that is all three angles added together, will make up 180 degrees, because this is a triangle. Now, the first thing I want to do is to duplicate this left-hand side of the triangle. Let's duplicate this line and then move it along to the other side so that we have a parallel line, because it's exactly the same angle. So these two lines are parallel to each other. Now let's consider this angle here that we mark with a red dot. Let's mark this angle. Can you tell me which angle is the alternate angle of this angle? Which of the three angles within the triangle is the alternate angle? Well, we can work it out if you remember our rule about the Z shape. We can see that we have a Z shape formed, and within this Z shape it's very easy to find the alternate angle. So we can see that the angle that's at the top of the triangle is exactly the same as the angle we've started with, this angle here, the outside angle on the right. They are alternate angles to each other, which means they are exactly the same angle. Now let's try something else. Let's extend the bottom of the triangle out to the right, and we want to examine another angle. This time we're going to try to find the corresponding angle of this angle that we're trying to find. This is our angle here. Now let's mark it with a green dot. Can you tell me what the corresponding angle to this angle is? What angle inside the triangle is a corresponding angle of the angle marked with a green dot that's outside the triangle? Can you find a corresponding angle? Well, you may remember from earlier on in the lesson, we showed that you can find a corresponding angle by looking at the F shape. So if we see where the F shape lies on this triangle, you'll be able to find the corresponding angle. So there's our F shape. Now, where is the corresponding angle inside the triangle? Well, by looking at the F shape, you should know that it's here. So the angle that's outside the triangle, the one marked with the green dot, is exactly the same as the one inside the triangle marked with the green dot, because they're both not alternate angles, they are corresponding angle. So the angle outside and the angle inside are the same size. So we now have two of our angles. We've got the red angle, and we found that using the laws about alternate angles, and we've got the green angle, which we used regarding the laws of corresponding angles. There's just one angle left that we don't know, and it's the angle that's at the bottom right of the triangle. So what we've shown now using the rules of alternate and corresponding angles is that the two outside angles marked green and red are the same as the two angles inside the triangles marked green and red. The angle that's outside the triangle marked red is the alternate angle to the angle that's inside the triangle marked red, and the angle that's outside of the triangle marked green is the corresponding angle to the angle inside the triangle marked green. So those two angles are the same as the two angles inside the triangle. Now that we've done this, this just leaves us one marked angle. Now let's focus in on the three angles that are at the bottom right hand side of the triangle, the two outside angles and the inside angles. Let's isolate that. You can see that there are three angles there, and we have one unmarked angle. We have the green angle, the red angle. Let's mark the other angle. We'll mark it with blue. But what do we have here? We have angles on a straight line, and if you remember from previous lessons, you will know that the angles on a straight line add up to 180 degrees. So we can use this idea that the angles on a straight line add up to 180 degrees and say that all three of these angles must add up to 180 degrees. What that means is that red angle plus the green angle plus the blue angle must add up to 180 degrees because they're all on a straight line. So can you see that? Can you see that those three angles, the blue dotted angle, the red dotted angle, and the green dotted angle, are all on a straight line, and they make up all the angles on that straight line? And so that means that red plus blue plus green must be 180 degrees. So now for the final act that we must do. let's remove the two outer angles and look at what we have left. We have a triangle with three marked angles: green, red and blue. But if we look down at our sum below, we've seen that green plus red plus blue equals 180 degrees, which means that the angles, the internal angles of this triangle must absolutely add up to 180 degrees. So there is our proof. The angles within a triangle add up to 180 degrees. And we've been able to prove this using parallel lines, corresponding angles, and alternate angles. So now you know why we can be absolutely sure that the angles within a triangle must be 180 degrees, and so why we can use it, as we've done in previous lessons, to show how many degrees there are in the angles of any polygon, as long as we can divide those polygons up into triangles. So that's it for now. I hope you enjoyed the lesson and you learned from it. I'm going to do another lesson with a few questions just to make sure you've understood what corresponding and corresponding and alternate angles are, and we'll do that in the next lesson. So until then.